Today we are going to discuss about demultiplexer circuits. Demultiplexer circuits are exactly opposite to the multiplexer circuits which we have discussed in the last class. In multiplexer circuit, we have several input lines, and depending on the control input, the input is directed to a single output line. Here it is exactly opposite to that. Here you have one input line and several output line. In this diagram, the output lines are given number from 1 to n, and control inputs are numbered from 1 to m. So depending on the value of the control input, the input line to the multiplexer is directed to one of the output lines. So in short, it is denoted as a circuit which creates one into many lines. That is one input line which is directed to many of the output lines. That output, which output line is required, that is decided by the control input 1 to m. So value depending on the value of the control input, the input is directed to particular line in the output line. So this is the block diagram. We have input line, control line varying from 1 to m, and the output line varying from 1 to n. This is the block diagram. Now how do we practically implement a 1 to 2 demultiplexer? That is, you have one input line and you have two output line. Now how do we implement this one? This can be implemented by using AND gates and NOT gates. So from the figure, it is shown that D is the input line. So here this D represents the input line, and this input line is connected to both the AND gates. So to this line, this D is connected here, and to the bottom AND gate also D is connected. Now you are having a single control input, that is A. A is the control input. So A is connected to the lower AND gate, and the inverted A bar is connected to the upper AND gate. So now what will happen when A is equal to 0? When A is equal to 0, that means your control input is equal to 0, means the lower AND gate is completely disabled, because this Y1 AND gate corresponding to Y1 is disabled because A is equal to 0. So whatever be the value of D, the output of the lower AND gate will be 0, because A is equal to 0. Since A is equal to 0, A bar equal to 1, which means the upper AND gate is enabled. So the output Y0 is generated depending upon the value of D. If D is equal to 0, the Y0 will be 0. If D is equal to 1, Y0 will be 1. So that means the value of D is directed to the upper line, that y0, since a is equal to 0. Now what will happen if a is equal to 1? If a is equal to 1 means the lower AND gate y1 is enabled and upper AND gate is disabled, because a is equal to 1 means we are inverting using a NOT gate, which means a bar will be 0. If a bar is equal to 0, if any one of the input line to the AND gate is 0, means the AND gate is disabled, output will be 0. So in that case, the lower AND gate is enabled. So D will be connected to Y1, which means the Y1 will produce output value depending upon the value of D. D is equal to 0, Y1 will be 0, and if D is equal to 1, Y1 will be 1. So this is how we are implementing 1 to 2 demultiplexer. Next, 1 to 4 demultiplexer. That means you have one input line and you have a 4 output line. So here I represents the input line, and Y0, Y1, Y2, Y3 represents the output line. That means there are 4 output lines, and if there are 4 output lines to be generated, then you have to be controlled, then you have to choose two control inputs. S0 and S1 represents the control bits, and YI is the input line, and this 4 are the output lines. So what you have to do is choose one of these 4 lines depending upon the value of S0 and S1. So we decide the values of S0 and S1 in such a way that I will be directed to one of the lines depending on the value of S0 and S1. So Now we'll consider what are the options available. So if usual convention is that if you choose S1 equal to 0 and S0 is equal to 0, that means 0 0 corresponding to output uh, the corresponding output will be y0. That means we are choosing y0. If s1 is equal to 0 and s0 is equal to 0, then we are choosing the output line y0. And if it is 0 1, we are choosing y1, 1 0 corresponding to y2 and 1 1 corresponding to y3. That means if there are two input lines, you can generate 2 to the power n. So n is equal to 2 in this case, so 2 square, that is 4. So we can choose between 4 output lines. So the Boolean expression can be written as y3 equal to, this y3 will be high only when s0 and s1 are high. Okay. So we choose s1, s0, y1, I, s0, s1, s0, I. So I is the input line, and y2 will be high only when s1 is equal to high. So s1 and s0 is 0 actually in this case of y2. So we are inverting this s1 s0 bar I, and the second y1 corresponding to s1 bar s0 I, and the last one, the first one, so the first one is corresponding to s1 bar s0 bar I. So if there are if this input line is low, then you have to choose the inverted line, and if it is high, you will keep the um, circuit as such or the value as such. Okay, so y0 corresponding to s1 bar s0 bar I. Now, how do we implement this one? This can be implemented by using 4 AND gates and 2 NOT gates. So you have the input line I. This is connected to all the AND gates. Okay, through this line it is connected to all the AND gates here and here and so on. So all the 4 AND gates are connected by uh, this I line. I line is connected to all the 4 AND gates. Now you have to choose between S1 and S0. So what we are doing is here you have S1 line. So S1 line is taken this one this way, and S0 bar S1 bar is taken. This S1 is connected here. It is inverted by using AND gate. This becomes S1 bar. And similarly, you have S0 line and this S0 bar line. Now, what you have produced depending upon the expression, this expression. So for y0, you have to connect both S0 bar and S1 bar. So here you can see this is S0 bar line. Okay. This is S0 bar line. So this S0 bar line is connected here to y0, and similarly S1 bar line is connected here, and I is already connected here. So this corresponding to this line. This S0 bar corresponding to this line. Similarly, for y1, what you have to do is you have to connect S1 bar. So S1 bar is this line, it is connected. And whether S0 is connected, yes, S0 is this way, it is connected here, and then the I line. And this y1 corresponding to this. Similarly, y2 have to connect s1. Y2 we have to connect s1. So s1 is this one, this line. So this s1 is connected through this line, and s0 bar is connected here, and I is connected. So this y2 is this one, and the last one is directly connected. S1 and S0 are directly connected to y3. So this is how we are implementing. Just by using AND gate and NOT gate, we can implement a demultiplexer circuit. And the last point is 1 to 8 demultiplexer. So the idea is saying, but you require 3 control lines. So one input line, and there are 8 output lines. Okay, and in order to control these 8 output lines, you require 2 raised to n number of inputs. So this 2 raised to n equal to 8, which means you have you required a value of n equal to 3. Okay, so this n value is required 3. So that is why we are using 3 control lines. So how do we implement this one? It shows this way, and idea is same. So here input line corresponding to D. Okay, So S0, S1, S2 bar 0, all 0 corresponding to Y0 line high D, and 0010 corresponding to Y1, then 0100 corresponding to Y2, and 011 corresponding to Y3, and so on. So you have to choose between 0 corresponding to first line, 1 corresponding to second line, 2 corresponding to the second, when 2 corresponding to the third line, and so on. Okay, finally this corresponding 8 corresponding to the last, when first line, y7. Okay, so each value 00 corresponding to 0, 1 corresponding to 1, and so on. So you have to uh, choose between different lines by giving different values to S0, S1, and S2. Now, how do we implement this one? Implementation is also looks complicated, but it's very simple implementation circuit diagram. B is connected to all the AND gates. Simple. Uh, this line D is connected to all the lines. Very simple way you can connect it. And now you have to choose between S0, S1, S2, and corresponding complement lines. So you generate an S0 line here. Fine. Now you invert this one and create one more line. So this line corresponding to S0 bar. Similarly, S1 and S1 bar, S2 and S2 bar. So now you have to choose according to the expression. For the first line, what we required is all the inverted lines. So S0 bar is connected here. Okay, S0 bar is connected this line, and the second line corresponding to S1 bar, third line corresponding to S2 bar, and then corresponding to the one more line is appearing at the input to the first line. So this corresponding to the first column, in fact the last column in the truth table, this column. Okay, this column is represented by the first AND gate, and y1 is represented with the 1 0, that is 1 0 1 0. So 0 1 0 means S2 bar should be connected. Okay, S2 bar is connected here. Fine. Then uh, S1 bar is connected, and S0 should be connected. That is, it's not actually 0 1 0, it is 0 0 1. This should be 0 0 1. So 0 0 1 means this is S2 bar, this is bar, and this is also inverted, and the S0. Okay, S0. So S0 is connected here, and all of the inverted lines are connected. And similarly for the second one, it is 0 1 0. 0 1 0 means the only this first second, I mean 0 line is connected, 0 bar line is connected, and then S1 line should be connected. So check whether S1 is connected. Yes, this S1 is connected. Then S2 bar is connected. So in that way you can check it. For the last line, all the non-inverted lines, the original line is need to be connected. So this corresponding to this corresponding to the S0, this corresponding to S1, and this one corresponding to S2, and then D. So this is how we are implementing. So whatever be the line, whether it is 8 line or 6 line, 16 line, or whatever it is, you can implement easily. 16 line 1 to 16 demultiplexer, the control lines should be 4. So instead of S0, S1, S2, you have to use S3 also. That is the only difference. Then generate S0, S1, S2, S3, and then corresponding complement. Then each line should be chosen carefully in such a way that the truth table can be implemented properly. And that's all in this class. Thank you.